let's go ahead and take a look at finding the area underneath our curve between 1 and 5. And we're going to try this one with 20 rectangles. So we have our function, it's graphed right here, and it's shaded in from 1 all the way over to 5. Now I didn't actually go ahead and draw in all 20 rectangles. But we want to go ahead and do our sigma notation. This is for our left endpoint rectangles. This is for our right endpoint rectangles. In both cases, we need to start out with our sigma. We need to put our function here, which is our input squared plus 2. So what I have in blue is representing this because our function's input squared plus 2. We then got to multiply it by our width, and that's what we'll put here. Now, our width, in this case, we're going from 1 up to 5, which is a width of 4, dividing it into 20 equal parts. So 4 divided by 20 reduces down to a 1/5. Now, what we are putting in here for our x, instead of writing x, we got to put something in there. To be able to figure out what we put in there, we look at our x sub 0. X sub 0 is always where you begin. In this case, it's 1. X sub the number of rectangles, in this case it's 20 rectangles, is always where you end, which is 5. All we have to do is basically figure out the equation of the line that goes through the point 0, 1 and the point 20, 5. So you know to figure out the equation of a line, you got to do your slope. So you do 5 minus 1 over your 20 minus 0, and that's your slope. So when you're looking at the y is equal to an mx plus b, your slope, 5 over 20, sorry about that, that's a 4 over 20, is a 1/5 for your slope plus your y-intercept. Your y-intercept is this point right here, because your y-intercept is what you get when you plug in 0, and it says we get out 1. This is what we got to write in our parentheses instead of writing x. So we're going to go a 1/5. Notice we're dealing with k. So instead of writing x, I'm going to put k plus my y-intercept of the 1 right here. Not necessarily the y-intercept of the graph. We're looking at the y-intercept of the line that goes between these 2 points. If you're looking at your left endpoint rectangles, which would be this one here, it goes up to 1 less than the number of rectangles. Now, that's for your left endpoint. This is for your right endpoint. It's no different other than your 2 indices change. So for your right endpoint, you're going to start out with k being 1, go up to the number of rectangles, which is 20. All the rest of this stays the same. We don't have to refigure out all this because it's identical whether you're dealing with left or right. So it's that 1 over 5 k plus 1 all squared plus 2 closure bracket, and then still times your width of 1/5. So let's go ahead and do the same type of process on this problem. We're looking at our area from 2 over to 7, and we're doing 15 rectangles. So we're going to do our sigma. we got to put in our function. Our function here is input squared plus 2 times your input plus 4. So that's this part right here. Then we got to go ahead and multiply it by our width. Well, to get our width, we're a total width of 5 wide, dividing it into 15 pieces. 5 over 15 is 1/3. Now, instead of going ahead and putting in an x, we got to replace our x's with that special equation. So we got to replace these right here. So we got to look at that x sub 0. X sub 0 is always where you begin. X sub the number of rectangles is always where you end. So then you want to go y is equal to mx plus b. We really have our point here of 0, 2, our input and our output. Our input and our output. Figure out our equation of our line. So we're going to go find our slope, change in y over change in x. So we get 5 over 15, which is a 1/3 times x plus our y-intercept. And our y-intercept is always what you get when you plug in 0, and we have 2. That's what we have to put in these two spots where there initially was an x. So we're going to go 1/3. Our value, or our variable is k, plus 2. And we got to put it in our other x location. Now, if we were looking at a left endpoint, we would put a 0 here, and we would go to 1 less than the number of rectangles. This is your summation notation for your left endpoint. If you were looking at right endpoint, none of this here changes, and you would have a 1 here, and then you would go to the number of rectangles.